Have you ever asked an AI to write a joke or a story, and what you get back is, well, it's technically correct, but it just feels a little flat, a little predictable? If you have, you've actually stumbled onto one of the biggest puzzles in artificial intelligence right now, the creativity problem. Okay, let's dive into this, because some brilliant researchers may have finally cracked the code on how to teach an AI to make a genuine creative leap.
I mean, it's the big question, isn't it? These large language models can write essays, they can write code, they can even whip up poetry with this stunning fluency. But when you really push them for true originality, that spark of unexpected genius, what you get back often feels like a clever remix of stuff it's already seen, not a truly brand new idea. And this little comparison illustrates the difference perfectly. The human joke, it has a plan, right? It sets up spies and shoes specifically to connect them with a clever, surprising punchline, sneakers. The AI joke, on the other hand, is logical. It just combines the words into footwear operative. It makes sense, but it's missing that spark, that pre-planned aha moment. See, it's just predicting the next logical word, not planning a brilliant punchline from the get-go. So let's actually put a name to this feeling. Why do these incredibly powerful systems sometimes feel so, well, predictable? It turns out this isn't some kind of bug. It's a direct result of how they're built. And it's a puzzle that researchers have really started to dig into and solve. The heart of the issue is what researchers are calling a leap of thought. It's that moment of insight, that little eureka that connects totally different ideas in a new and surprising way. Right now, a lot of AI output feels like it's just shuffling familiar concepts around, not truly inventing a new connection from scratch. Now, if you want to fix a problem like this, you first have to be able to measure it. So these researchers designed a series of really clever algorithmic tasks to isolate and actually quantify the building blocks of creative thinking. This is where we get to peek under the hood and see what's really going on. And here it is, the key definition from their work. A leap of thought isn't just a random guess. It's a planned process. It's something that happens before a single word gets written. Just think back to that sneakers joke. The punchline had to be planned in advance to make the whole setup work. It's this advanced planning that's been missing from our AI. So, inspired by cognitive science, the research team isolated two fundamental types of creativity to really put AI to the test. Let's break them down. First up is combinational creativity. This is all about making new connections between ideas you already know. To test this, the researchers created an abstract task they called Sibling Discovery. Now, this is a perfect parallel to our spy joke. The AI has to find two sibling concepts, like spies and shoes, that are connected by a shared parent concept, which in this case is the punchline, sneakers. It's a really clean way to measure that aha connection. The second type is called exploratory creativity. This one's a little different. It's about inventing brand new patterns that have to follow some kind of hidden global rule. Their test for this is called circle construction. The AI has to generate this jumbled list of connections that, if you were to rearrange them correctly, form a perfect circle. Think of it like designing a really satisfying puzzle. The final solution is elegant, but the creator has to invent and plan that entire hidden structure right from the start to make it all work. Okay, so with these clever tasks, researchers could finally put a number on creativity. And in doing that, they identified the one thing, the single core mechanism that was holding AI back. And here's the crucial insight. The problem isn't with the sophisticated neural networks, and it's not the massive data sets. It's something way more fundamental. It's about the single core objective that almost every large language model is trained on. And that objective is called next token prediction, or NTP. It's a simple idea, but it's incredibly powerful. The AI gets shown billions of sentences, and it's trained to do just one thing, relentlessly, guess the very next word. That's its whole job. It becomes a master predictor. But this creates a fundamental problem, myopia, or short-sightedness. It's kind of like driving a car, but only looking at the patch of road 5 feet in front of your bumper. Yeah, you can stay on the road, but there's no way you can plan for a complex turn that's a mile ahead. NTP is great at making sure sentences sound right word to word, but it has zero incentive to form a long-term creative plan. And the researchers, they say it directly. Next token learning is myopic. It's short-sighted. To get that leap of thought, you have to be able to see more than just the very next step. You need a totally different approach. Which brings us to the really exciting part, the solutions.
See, the researchers didn't just diagnose the problem, they developed two breakthrough methods to actually teach an AI how to plan ahead and make that creative leap. And these two solutions, they attack the problem from completely different angles. The first one fixes the training process itself, forcing the model to think globally. And the other reimagines where creativity and randomness even come from in the first place. The first breakthrough is called multi-token prediction. So instead of training the AI to predict just the next word, this method trains it to predict all the words in a creative structure at the exact same time. It's like giving it the entire map of the journey instead of just telling it the next turn. It's forced to learn the global pattern to succeed. And get this, the results are just staggering. Just look at the difference on this chart. On that sibling discovery task, the standard model scored a measly 0.04, but the model trained with multi-token prediction, it scored 0.40. That is a tenfold increase in its ability to generate these novel, creative connections. That is a massive leap. Now, the second breakthrough is even more elegant, I think. It's called seed conditioning. Normally, when we want to get different outputs from an AI, we kind of jiggle the probabilities at the very end of the process. This method completely flips that script. It injects a little bit of randomness, a seed, right at the beginning with the input prompt. And the results here are just as stunning. Standard randomness methods, like what's called temperature sampling, they barely move the needle on creativity. But seed conditioning, even with a totally deterministic, predictable output process, it achieved that same incredible creativity score of 0.40. What this suggests is that giving the AI a unique random starting point lets it flesh out one creative idea with a singular focus, instead of trying to juggle a bunch of possibilities at once. Okay, so we've got these new ways to train AI that make them dramatically more creative on these abstract tasks. But why does any of this matter beyond, crafting better jokes or making cooler puzzles? Well, it matters because the same kind of leap of thought that's required to write a good pun is, at its core, the same kind of thinking that's needed for major scientific breakthroughs. This isn't just about art. An AI that can truly plan and invent could help us design new medicines, discover new materials, or even generate totally new hypotheses to tackle problems that we just haven't been able to solve yet. Ultimately, what this work represents is a fundamental shift. We're starting to move away from an AI that is just a superpowered prediction machine and toward an AI that can be a genuine creative partner, one that can plan, strategize, and invent things that are truly new. This all shows that the limits we see in AI today aren't necessarily permanent. They might just be artifacts of how we've been teaching them all along. And by changing the lesson plan, we might just be unlocking a future that we can't even predict yet. The only real question is, once AI truly learns how to leap, where is it going to land?